I'm Jennifer Flatte, and I'm one of 4 founders and the CEO of QuantCAD. And our mission is to enable the development of quantum devices by solving noise problems and then distributing them in a fair and an equitable manner. So what's a noise problem? Well, remember when we were kids and we played telephone? And the person at one end of the line leans over and whispers into their neighbor's ear, "Johnny made a peanut butter and jelly sandwich." And it goes all the way down the line to the other end, and the person at the far end of the line stands up and shouts triumphantly, "The weasels have taken Mr. Toad to the hovercraft." That, my friends, that's a noise problem. So in quantum, noise is the static in the line. It's the reasons the qubits don't talk to each other. It's the extraneous output that hides the real data. And as we all know, noise is a significant problem for quantum technology, unless you're developing quantum cryptography, in which case you really like noise. But for quantum sensing and quantum computing, solving noise is fundamental to ensuring that the output of your device is both clean and correct. So as quantum computing moves into the era of error correction, understanding the source and the type of noise in the system is essential to developing the appropriate and the accurate algorithms in order to mitigate it. So if we solve the problem of noise, we will accelerate the development and the distribution of devices based upon quantum technology. It will also put the speed, the sensitivity, and the durability of quantum devices into the hands of the people and the industries that could use it the most. So here at QuantCAD, we approach this problem from 2 directions. We're primarily a software company developing simulation tools that run on classical computers. And our semi-empirical tools will help device designers and engineers determine the best materials, the best orientation, and the best position of components within a device to ensure appropriate sensitivity and readable output in real-world environments. Cadtronics focuses on the material properties of layered semiconductors and is used to develop optoelectronic and spintronic devices, and it's currently on the market. Using Cadtronics prefabrication significantly reduces both development time and the number of iterations you need in order to get to a viable product. Cadtronics can also be used to trace why a particular iteration isn't performing optimally. So if you're developing devices that use midwave or long-wave infrared, LEDs, infrared cameras, let's talk. Now, QNoise is a simulation suite that focuses specifically on optimizing quantum devices for reduced noise. And QNoise is structured around calculating spin coherent effects. We expect to have a beta version of QNoise available later this year. And then, in a bit of a pivot, we're actually testing QNoise in-house and using it to build prototype quantum magnetometers, which are small, light, have minimal power needs, and are capable of functioning in a variety of extreme environments, including 500 degrees Celsius. So while NASA and the DoD have some obvious uses for these types of devices, we believe they'll also be successful for things like geographical or geological surveying, navigation in GPS-denied environments, as well as remote sensing in hazardous settings. So, what can we do together? Well, I am so glad you asked. If you're working with layered semiconductors and are wondering why your device is not doing what you expect, Cadtronics can help. If you're developing quantum devices and you want to address the noise in the system, then let's talk about what you're looking for and what your issues are so that we can build out QNoise with your needs in mind. And if the idea of maximizing size, weight, and power in a sensor magnetometer that can function at 500 degrees Celsius or the cold of deep space really excites you, then help us move our prototypes from the lab into fabrication. If you've got noise, get quiet with QuantCAD at quantcad.com.